I enjoy when you guys keep cameras on, but because I can see people. So your study set. So again, hopefully you've uploaded it. And Terry, yeah, thank you. You can do whatever you want. So physical properties, when I ask that question, that's talking about boiling point and solubility. So those are the two physical properties that we'll be talking about. And so kind of keep that in mind. The study said, I'm just looking to see that you made your best effort and that you turned it in. Solubility, they are both hydrophobic. So water, not water soluble. That was the lab from last week. And boiling point is going to be similar as you increase the carbons, as you increase surface area. You increase the boiling point. So they're both similar, so similar. Chemical properties are very different. Unsaturated double and triple bonds are highly reactive. And that's what tonight's lecture is on. Saturated are very stable, meaning they're not, so they're very stable, not reactive. So inert, they're like noble gases. They're what everything ends up as, that all the extra pieces react and are gone. So they're not reactive. I did one last week, or I'm sorry, in the last class that was on the study set. Yeah. All right. So 6 carbons, and normally our normal pieces we double and add to. That's like our starting place for an alkane. So that would give us 14, but every double bond you lose 2. So this would only have 10 hydrogens. And so this is 6 with 3 double bonds. We lose 2 more, so this would have only 8 hydrogens. Cyclic, so we would double, no multiple bonds. It just means you straight double for a cyclic. And 8 carbons. So normally it would be 8 carbons and 16 hydrogens, but every double bond you lose 2. So we end up with 8 hydrogens. Questions with that one? So every double bond, yeah. All right, so that's the idea on that one. The name game, we just number 1, 2, 3, 4. Double bond always gets the number, lowest number possible. So this is a 2-butene. Now, this does not designate the cis trans, so we can't give it a cis or trans, but typically when the double bond's in the middle, we will do a cis trans. It just doesn't indicate it. On this one, 1, 2, 3, 4, 5. So the double bond, triple bond takes preference. It has to be at the lowest number possible. The number you give it is the lower of the 2 numbers. So this is 2-pentene. Again, please be careful about the ending that you show ENE, because that's saying, hey, we have a double bond at number 2. There's 5 carbons. And then at 2 and 4, I have methyls. So 2,4-dimethyl. And then 2-pentene. All right, these are cyclohexenes. And on the cyclo, the double bond is always 1, 2, and you want to number towards the side group. Since the double bond has to be at 1, 2, we don't put a number for a cyclohexene, but we do for the side group always, even though there's only one side group. So it's a 3-methyl cyclohexene. And this one, it doesn't matter, it's symmetrical 1, 2, 3, 4, 5. No matter how you would do it, the double bonds would have to be like that. So it's a cyclopenta pentadiene. In this one, there's only the double bonds. If there's two of them, there's only one place they can be. So it's a cyclopentadiene. That thing would be crazy reactive. I didn't even know they could make that. I think somebody could just draw it. All right, and so our favorite gnome game. So we make a drawing, and you can do zigzags or you can draw carbons. I'll do this one as a zigzag. I'm going to put my double bond there at 4. I'm starting here, and then here I'll put my methyl. So I'm saying 1, 2 methyl, 3, 4, 5 is my double bond. So now I have to number it correctly. So this is where using a different color is nice. The double bond takes preference. The double bond has to have the lowest number possible. It doesn't have to be at number 1, but it has to be the lowest number possible. If there's no double bonds, we're back to the saturated. The side group takes preference, but now the side groups just end up where they do. So it's a 4-methyl. So if we change our name, this would be a 4-methyl, and we'd put the 1 for the pentene. So 4-methyl, 1-pentene. On these, you have to have a number for the pentene. Even if it's at number 1, you have to tell me it's at number 1. All right, on B, we can do our zigzags of 5. At the middle one, we have a methyl, and then it's saying 1, 2, we have a double bond. 3, 4, we have a double bond. So the mistake is just it was numbered backwards. So it should be 1, 2, 3, 4, 5. The methyl is still at number 3, and the double bonds are now at 1 and 3. So it is 3-methyl, 1,3-pentadiene. Again, I'm going to just keep going unless somebody has a question. All right, cyclopentene. If we're saying this is 1, 2, you're saying at 3 to 4 is my double bond, and at 3 is my methyl. Kind of weird. So 1, 2 has to be the double bond, and so the methyl will put it number 1. So we would just say it's a 1-methyl, and cyclo gets no number. I'll ponder that one. That one's kind of interesting. So on a cyclo, because the double bond's at 1, 2, if there's a side group at the double bond, that side group gets to be at number 1, but you have to tell me it's at number 1. So it does get a number. That just does not. And then cyclohexene. Again, it was numbered wrong, 1, 2, 3. So they're putting the methyl at 1 and 2. And they put the double bond at 3 to 4. So the double bond has to be 1, 2. And the side groups will now be 3, 4. No number there because it has to be 1. All right, so normally I ask, how'd you do on the gnome game? And people give me a thumbs up. So you can give me a thumbs up in your box. You can do a reaction and say, oh, I got it, thumbs up. Yeah, I knew Emma would do that. Like, kind of bummed nobody else. The rest of you haven't figured it out. Oh, I have a new trick I can do. I'll have to do it after we do this. All right, so we're going to name these. The double bond has to be at the lowest number possible. So 1, 2, 3, 4, 5, 6, 7. So it is a heptene. Make sure you make it an ene. You don't have to underline that. So hepta for 7. We have to put a number, which is 2. And this one has an extra piece. Because it did the zigzag, my double bond's in the middle. This is a trans. If you remembered the trans, you give me a thumbs up again. If you don't. All right, this one is heptene again. This is the exact same thing. I don't know if you guys saw that. It just flipped it. It's the exact same thing. So it is again trans 2-heptene. Cis or trans is always written at the very beginning. Again, it's not a hyphenated. All right, so again, so 1, 3, 5, 7. So heptatriene. So you're trying, you're all trying your best. That's all we ask for. There's so many wonderful jokes that we can do. with enes and ines. I should make that a bonus email that you have to come up with your own clever. All right, you can do that on the bonus on the worksheet. If you can't draw a cartoon, you can make a really fun joke up with a diene or a triene. And they need numbers. So 1, 3, 5. Heptatriene. The tri goes before the ene because there's 3 enes. Now, we have to do cis trans. There's a trans and there's a trans. So we transit. You have to do it. You don't say ditrans. You actually write trans, comma, trans. And anyone, yeah, with some, that's the notes from the other day. Anyone with organic chemistry, wizardry, sorry, would know at number 1, it can't do cis trans. All right, so this one, we have the 1 is over here because the double bonds have to be at the lowest numbers possible. So this is 2, 3, 4. So this is a heptadiene. When you have a di or triene, we add the A so we don't run consonants into each other, and we just say 2, 4. And they are both trans. So we get a trans again. So trans, comma, trans. Technicality, there's no dash or anything between the number and trans cis. There's commas between numbers, a dash there. Questions on this page? All right, I'm gonna flip it. Does somebody have a question? Maybe?
Yeah, I did. So pretty much when there's multiple double bonds, would always put trans every time, then correct?
If you have multiple trans. In the zigzags mean you have trans if the double bond's in the middle. So again, this one here, this number 1, sorry, I'm off the camera. This number 1 is not cis or trans.
Okay.
But when the double bonds are in the middle, like all my other ones, they're all trans. All of those in the middle are trans.
Got it.
Yeah.
Perfect.
And so if you have multiple, if you have 2 trans, you actually say trans, like that. Anybody else?
Got it.
Thank you for the question, Vincent. All right, so 1, 2, 3, 4. So butene, and you need an, oh, I'm sorry, we're not numbering. We're not naming. I was on a roll, just joking. So cis trans, A is no. So at this carbon number 1, it has 2 hydrogens. So if either side has 2 hydrogens, it is not cis trans. Never ever. All right, here, this carbon, which would be number 1, it has a hydrogen and a chlorine. So that's okay. And then at carbon number 2, we have a hydrogen and we have carbons. So this is yes. It can do cis trans. It's not showing us which one it is. If we were to draw it, you don't have to do this, but we can make it like this. We make the hydrogens both point up, and then the CH2, CH3. So this would be showing it as a cis. And then you can flip the hydrogen and chlorine and make it into a trans. 2-pentene, absolutely, yes. Because if I did it with the zigzags, that would be trans. If I wanted to show it as a cis, it would be like that. That's cis. And then this, the carbons, it doesn't matter which one's 1, which one's 2. So we could put the chlorines opposite each other like that, or we could put them in the same direction since it's 1, 2. So this is trans, what I drew. So D is yes also. You put the chlorines facing both up or both down, that's cis. Now, the question didn't ask you to draw them. I'm doing that to help you because sometimes visually it is. So B, C, and D all are possible to make them cis or trans. On 8, you're just telling me which ones are. A is not. 8 is actually a really excellent question. So this carbon has 2 hydrogens on it, so that's why it's not. On C, C is yes, that is trans, because we're zigzagging. D is neither, because the carbon has 2 hydrogens. And B is yes, we have cis, because the bromines are pointing both up. All right, number 9. Sorry, true, false. So I didn't talk about a lot of this. Sometimes I put things on the homework that I know I'm going to forget to talk about in class. And so it's okay. Again, the study set, I'm just looking to see that you made your best try at it, and it's meant to be a learning experience. Hydrocarbons have low density. Hydrocarbons, so think of an oil spill. You've all seen pictures of oil spills. The oil is floating on top of the water because they are very low density. That is back to question number 1, physical properties. All the hydrocarbons, physical properties, not soluble, low boiling points, low densities. So A is wrong. Butene is not a greater because more carbons, the hexene has more carbons, so it would have the higher boiling point. C is wrong because they all burn. So flammable means that they combust, so all of them burn. Doesn't matter how many carbons. And so they were all wrong. Okay, so something else I wanted to mention is, so next week, Monday is a holiday, so we don't have class. So we only have class on Wednesday. I moved your lab. It's due by Monday. That's because I know some of you might like a nice weekend and stuff. And I'm going to be traveling, so I do not have office hours on Saturday this week. We're taking the train across the country to get back to Oregon. Assuming you guys don't float away or slide away in the mud by then. Yeah. So if you want your Monday off, do your lab for before Saturday. If you're doing a 7-day challenge, then get it in when your 7-day challenge is up. You guys have a midterm then in the 4th week. So 2 weeks from tonight is our first celebration. It is going to be show your work. So sometimes there'll be questions like this, and more for those of you who are new to me. I didn't do this on purpose. I just write the questions and don't realize that they all came out as false. So the celebration will be during this time. And so it will show up at 6 o'clock, and then you do it in class. It would normally be everybody would finish in under an hour, but I do give you the class time to do it because some people work slower and think through it slower. And I'm not going to babysit you on Zoom. I will be on Zoom. If you have questions, you can come on to ask questions, but you just do the test and then submit it. And as long as we stay honest, my class last term stayed honest. My other class did not, and so the rules changed. I've had situations where we have to change the rules. So for the first test, I assume that we're all honest, and as long as we stay honest, we keep this format. If you have a conflict, so if you work on Wednesday or you have choir or something like that, we just will have to talk next week, and we can work out when to do. And so we could do it. Some of you, I know we can do it just before class and stuff, and we will work it out. It always works out. All right, number 10. So this is wanting to know, if you have a multiple bond, you have to have 2 carbons. And so an alkene would be just a 2-carbon alkene, so C2H4. A cycloalkene, the smallest one you can make it to be a cyclo is propane. And so propane normally would have 6 hydrogens, but when we put the double bond, we lose 1. So that's what it's asking. Again, a question that's like, what was she asking there? We never saw something like that. And so now you have an alkyne would again be 2 carbons with a triple bond between them. And so it would just be C2H2. So molecular formula just means how many carbons, how many hydrogens. And then the simplest alkane is methane. It didn't ask you to name them, and this would have hydrogens like that. So this would be ethene. That would be the IUPAC name. It is commonly known as ethylene. So polyethylene is when you start hooking these up together. We'll talk about that. This is a cyclopropene. Again, it didn't ask you to do that, but somebody always asks. There'd just be one hydrogen on each side. This is ethine, Y-N-E, and this, of course, is methane. Methyl with a YL is always a side group attached, and because it's attached, you lose one of the hydrogens, so it's a CH3 attached to something. All right, these are, oh, this is looking at which one has more hydrogens. So propane has more. So as you add double bonds take away hydrogens. On C, propene. So they both have one double bond, cyclo loses hydrogens. Here, triple bond is losing, so propene has more. And then here they are the same. Any questions? And then number 12, isomers. Everybody always loves isomers. There were no isomers. How could it be a study set in organic chemistry without isomers? There were no isomers on your worksheet. That's what I was just thinking about. So this is no. So the double bond, this would have 3 carbons and 6 hydrogens. The cyclo, you lose 2, so it would have only 4 hydrogens. You don't have to write the formula, but no, the cyclo does not work. On B, this is yes. They both have 5 carbons, and they have 1 double bond. So the number of double bonds tells us the hydrogens are the same. So B, yes, they're isomers. On C, yes. Cis-trans means isomers. I wouldn't come back. I did want to mention something about cis-trans, and I don't know, maybe it shows up on the next homework set. Actually, if you also look at the syllabus, the day before, the Monday of the 4th week, so the Monday right before the celebration, the class is, I actually post like an old celebration and we do it as a class. So that will actually answer a lot of your questions about that. My goal is that you all get this, that you embrace it, and you are enjoying it. And that we might expand our consciousness in here of things more than just organic chemistry. It has to do with boiling point. My question is, here we go, it's gonna be our first bonus chance for today. Which one has the higher boiling point of these two and why? And you may want to
C.
No, I'm asking on C, does cis or trans
Oh,
have the higher
trans.
Yeah, why?
Because it has it could fit more carbons and hydrogens.
So it has to do, when we're doing boiling point,
Surface tension.
surface area.
Surface area.
Trans, because of the zigzag, trans do that zigzag shape. If we go back, and so the zigzag allows that it can stack, so you have more surface area. On cis, we look like this, so it has, yeah, it has to do with the trans has the higher boiling point.
Got it.
Okay. Sorry, I keep, all right, and then the last one, they're also isomers. So double bonds and cyclo, each one loses 2 hydrogens. Ine loses 2 hydrogens twice. So they both, these would be isomers. You could always count, we'd have 4 carbons and 6 hydrogens. So normally you double and then we lose 2. So they are isomers. So B, C, and D were all isomers within each question. And then number 13. So the problem with this propene, So we have 3 carbons, and we put the double bond would be 1 to 2. On propene, we don't put a number because it has to be at 1, or else you numbered it wrong. And that would be the methyl group. It's also known as isobutylene because it's 4 carbons total. However, the compound to do this does not exist. So what's wrong with that compound? Why does this get a big frowny face?
Because it's in contact with the double bond on 2.
Not quite. Anybody else?
Is it because there's too many bonds?
There's 5 carbons. Yeah, was that Kristen? Or
That
no?
was
Who was that?
Caitlin.
Caitlin. Thank you. Several of you have similar voices suddenly. It's like voices of angels is all I hear. So, all right. Yeah. So remember that game we played the very first class? This middle carbon ends up with 1, 2, 3, 4, 5. It has too many bonds. So I don't know why I wrote 5 carbons, 5 bonds, too many bonds. So that's why it won't work.
Got it.
All right.
Bonds.
Any questions on the study set? The thing that's really cool with the study set is in the notes. This is kind of what we're gonna start here, but like the polyethylene, the polypropylene and stuff. I'm gonna stop recording and then start again.